Okay, I think we can start. So hello and welcome everyone to our joint webinar with the Ambassador Labs today about bootstrapping Kubernetes with Ingress, dealing with day 1 and day 2 concerns. Damien, could you just mute yourself for a little more time? Thank you. Yeah, so my name is Caroline. I'm happy to see that you're joining the session today, even after such a long time of online sessions only, social distancing, and such an overload of virtual events. It's great to see that you still feel like e-learning and exchanging ideas virtually. I'm proud to introduce you to our 2 speakers for today's webinar, who is Daniel, who's the director at DevRel, and Damien, who works as a solutions architect at Kubermatic, and together they will be providing you with a comprehensive insight on what challenges you will be facing when moving through the day 0 to day 2 cycle. And they will be explaining you how to close the gap in implementation times with the help of automation and monitoring. But before we can jump into the exciting part, I'd just like to add some more organizational information. So first of all, if you have any questions during the presentation, please use the Q&A chat window below so that we either can answer them straight away or in the Q&A session right after the talk. And yes, we are recording the session, so you will get the replay in the coming days. You either will get it via email or you can find it on our YouTube channel or on the website. So there's a bunch of ways of rewatching the session whenever it suits you. Yeah, and with that, handing over now to Daniel. The stage is yours.
Super, thanks, Caroline. Great intro there. Appreciate it. Welcome, everyone. Great to see you. And I'll +1 all Karen's advice there. And thanks a lot for tuning in, because there is just so much going on at the moment, isn't there? It's awesome to see you. So we're going to be talking about bootstrapping Kubernetes with Ingress, dealing with the day 1 and the day 2 concerns. And for me, the day 2 concerns are always super interesting, right? So if we go to the next slide, please, Damien. This is myself and Damien. As Caroline mentioned, Damien's a Senior Solutions Architect, Kubermatic. I'm Director of DevRel at Ambassador Labs. You can find us on the interwebs. Get in contact with us. We love hanging out on email, GitHub, and so forth. Please do reach out and ask us questions. You know, if you can't answer your question in the webinar, find us online somewhere. Find us at an event. We'll mention about container days at the end. So container days coming up soon. Do find us. Do come and talk to us. Next slide, please.
Happy to be here.
So quick agenda, we're going to look at what are day 2 operations, because totally appreciate not everyone knows what they are. And more importantly, why should you care about day 2 ops? Damien's going to go in a nice Kubernetes architecture review, kind of 101, paint the big picture. We're then going to look at Kube 1 for sort of bootstrapping your Kubernetes world, or building the house, as the analogy I like to use. And then we're going to look at the Ambassador Edge stack, which is like your front door to your house, where everyone's coming in to access your services. There's going to be some live demos if the demo gods are with us. Damien's going to run through Kube 1, KKP, and I'm going to run through Ambassador Edge stack and dive in. And if there's time, there'll be some Q&A at the end too. Topics covered. So what are day 2 operations and how they impact you as a developer or a Kubernetes cluster user? There is subtle differences between those 2 personas, but we'll try and cover them both. We're going to learn about the need for automation, security, and observability. Now, these are 3 key things that Damien and I are going to talk a lot about. So automation, security, and observability are really valuable for day 2. I'm going to explore these concepts through the use of Kube 1 and through Ambassador Edge stack. So in terms of takeaways on the next slide, these 2 takeaways are the most important thing to remember. If you remember nothing else, right, from this webinar, these 2 things. The end game today is to provide a comprehensive insight into what challenges are most commonly found. So as we're going through the webinar, think about this. What are the challenges that I as a developer, I as an ops person, I as whatever role you play, what are the most common challenges that you will find as you move from this day 0, kind of bootstrapping, to day 2. And Damien and I are going to share a bunch of tips that, you know, not all of them relevant to everyone, but depending on what persona you're sort of operating in, what's developer operations, SRE, there's going to be some stuff that's going to speak to you directly. And yeah, hopefully it's useful. Let us know if it is at the end. We always appreciate the feedback. I think in that case, Damien, it's over to you to set the scene.
Excellent. Thank you so much. So the first thing that I would like to mention is that I like you to look at this snail, and this represents everything that we're working through from day 0 to day 2 in the operations when we're working in software development or when we're working in developing on a specific architecture. So you can think about this in a very, let's say, comprehensive way. So I like to call it the DevOps 2 snail. You're going to have the head, you're going to have the little house here, and then you're going to take off with your little product or your architecture. So it's going to make a little bit more sense here in the next slide. And this is why we call it the snail. Usually when we're working with implementations, you're going to subdivide this by phases. This is the way that it's usually been done in the last couple of years. And you're going to get a day 0 phase, a day 1 phase, and a day 2 phase. So if you turn this around, you're going to see that you got the day zero phase, which is the head. You're going to have your body, and then you're going to have the day 2, which is going to be the shell of this nail. When we talk about day 0, we're talking about the phase when you're during the planning sessions, when you're designing your product or designing your architecture, is the phase where you get together with your team and you get their requirements and you start working with what is it that you actually need and how you want to bring this to life. During the day 1 operations is when you get this design brought to life. It's very, very interesting because it's when most of the operations gets hands-on. It's when things become truly the product they're supposed to be. It's when you stick the most to making sure that, let's say, continuous integration and continuous delivery are starting to be planned ahead. But then that takes us to day 2. So probably you've heard this term quite a lot, and day 2 refers to when a product is ready and we're ready to go live. Is in this specific phase here where we're actually going to see how our application is interacting or our service is interacting with everybody that is actually using it. It's when we are going to establish the feedback loop that's going to give us a lot of the information to make this better. So what happens during day 2 and why should we care? So as I mentioned, day 2 is when your users are going to connect to that specific service. And it's the moment when things can either break, can be improved upon, can get better. So it's very important that we establish a feedback loop. And we can think about it in 4 phases. This is the way that I like to see it, and this is the way that I've seen it done before. And it's when we take the approach that usually refers to military jargon, of observe, orient, decide, and act. And we're going to focus on how the user interacts with the service. So during the observation phases is when we are going to get all the information from the monitoring systems that you have. So we're going to get to this in a couple of slides, but in Kubernetes it's very important that we have a very strong cluster to monitor the operations. Then we go through orient. It's when we perform root cause analysis of any issues, of any feature we actually want to improve upon. And based on this information, we decide what is the step that we're going to take upon, and then we act. We either implement a solution or we can also do changes accordingly. So we care about this because by adding to the mix cloud computing, microservicing, Kubernetes, different types of architecture, this makes that things can get very complicated. So automation and orchestration of the services is really important to make sure that everything is working together. It's very important also that these tasks are repetitive. It can get boring. I personally know by firsthand that monitoring a system can get boring, but it's very important because it's when the system is generating information to improve. And it's always key, this monitoring, because if you're not completely familiar with what's going on in your application, then you can't deliver maximum benefits upon what is actually going on with it. So you can think about day 2, about the actual action of keeping the lights running in your services. It doesn't matter what happens, you gotta keep the lights on. Because as you see here, you can schedule your deployments, you can schedule your upgrades, you can schedule everything, but you can't schedule when things break. And you gotta be ready for when this happens. So why this is important? Because the bigger things grow, and the bigger the amount of offerings in the market grow for monitoring, cloud solutions, containers, microservices, multi-cloud, hybrid cloud, these add a lot of complexity. And there is always an intense amount of work that it's involved in keeping the systems healthy. Just keeping ingress and egress rules can be very complicated if you're not very familiar with it. So by automating how things are going to get fixed and removing the human operator from the infrastructure and these processes can help you go and make things better, because process improvement manual ones can only go so far. Up to you, Daniel.
Yeah, well said, Damien. I've definitely been on that side as well, where I was like an SRE or an ops person, and I realized I was not good at the things repeated over and over again, right? I just drifted off, I, make mistakes, these things happen. And to Damien's point, with containers, microservices, multi-cloud, hybrid cloud, there's just more and more things. There's more layers in your infrastructure stack, and there's more modules, microservices, in your application stack. So totally need to have some process and some hierarchy in terms of how you control these things. And I sort of hinted earlier on in the intro, but KKP, which Damien's going to run you through later on, automates the infrastructure. It takes the blueprints, if you like, and builds the houses, right, on demand repetitively. The Ambassador Edge stack is all about getting traffic from your users to the backend services. It's the front door of your cluster, right? So you may have many different clusters, but each cluster needs a front door. And these are two critical things, right? Taking your blueprints for your house, building them on demand, having a hierarchy where you can report up metrics, these kind of things, but then critically being able to get traffic into your backend in an observable and secure way and a reliable way. Well, that's where Ingress comes into its own. Always like to do a bit of a primer on what Kubernetes Ingress is. Now, the Ingress spec has been debated for many years in the Kubernetes world. Ingress itself is a fundamental concept. I'm sure many of you bumped into Ingress via, cloud, load balancers, proxies, these kind of things. Ingress is fundamentally traffic coming into your cluster, into your domain, if you like. Within Kubernetes, there is a specific Ingress type entity or entities. So if we go back a minute, hold on. There we go. What I was going to mention is Ingress resources contain routing rules. So these are, this endpoint, so / payment service maps to this backend service on this port, on this protocol. The Ingress controller takes those Ingress resources and makes it happen, right? So the Ingress resources, it can be Kubernetes Ingress resources. You can use custom resources, which we do in the Ambassador Edge stack, but they define the map, if you like, the kind of like the things you want, the declaration of what you want, and the Ingress controller makes it happen. And the Ambassador Edge stack is an Ingress controller, takes the instructions, makes it happen, configures your front door accordingly, secure, reliable, observable. We'll go to the next slide, please, Damien. Each Kubernetes cluster does provide its own network namespace, its own isolated network namespace, which is great because it means you can share have the same namespace effectively, same CIDR block, same IP range, many different places, but they're isolated, so they don't overlap. Now you can address each pod, which is sort of the smallest unit in Kubernetes, if you like. It's not a container, it's actually a pod. Pod has a few containers, kind of like fundamental service unit of deployment. Now each pod has its own easily accessible IP address, but you need a network bridge. This is the concept of the load balancer of the Ingress that bridges that outside world to the internal world. And again, this is what Kubernetes Ingress, something like Ambassador Edge stack, does. So back to you, Damon, and now for some KKP and Ambassador Edge stack overview.
Excellent, thank you. All right. So one of the main things that I want to take here is that, as Daniel mentioned, KKP, which stands for Kubermatic Kubernetes Platform, it's an orchestration tool. It's essentially an orchestration tool that is going to allow you to connect several places and several different clouds into a single straight-up location from where you can actually control everything else that you're doing. It can work as an infrastructure as a service if you want it, and it's going to help you out to build everything that you desire to build, and depending the architecture that you want to work in. So in this diagram, as you see here, any orchestration tool needs to have the ability to connect to different clusters and be able to handle the master clusters and the worker nodes in a fashion that it can centralize the amount of information that you're working with, and you have visibility over everything that we're doing. Which brings us to why do we select this stack with the options that we have available? And it's because Kubernetes has a new way of managing the workload. And for those of you who have experience in Kubernetes, you might be familiar, as I am, that as things grow bigger, things get complicated. Namespaces, subdivision, clustering, upgrades of your applications, all of this can get very, very, very convoluted. It can get very hard, specifically managing the rules that are governing these clusters by one themselves. And we wanted to apply a lot of these DevOps approaches into the way that we manage the clusters. We wanted to do it in a declarative way and actually move a little further away from just the scripting, because declarative is going to make life easier in a lot of the tasks that you need to perform. So in search of that, we built Kube1. So to give you a very high level overview, like a 10,000 feet level overview, the Kubermatic Kubernetes Platform, it's an orchestration tool that can work with multiple clusters in a multi-tenancy fashion, meaning that you can connect different providers, different cloud providers, different on-prem or hybrid clouds into a centralized locations when you're going to be automating most of the DevOps operations. It has a lot of the tasks that you will normally do or will normally get handled by a team centralized to a small centralized group of people. So for example, the lifecycle, containerized control plane, the debugging and the updating of the application, backups, enforcement of the Kubernetes versions, all of these tasks that as a DevOps engineer or a site an SRS, you will have to perform manually. So we make sure that we cover at least when we build a stack to make our life easier, that we cover the most important pieces of it, which is what you see in the screen, including the policy management. So when we're working in a Kubernetes highly hybrid cloud or multi-cloud environment, governance of the data, it's very important where the data is stored. If we're working in Europe, we want to make sure GDPR is applied. If we're working in the States, we want to make sure HIPAA is compliant. And we want to make sure that everything stays where it is. So as I mentioned, this can work in many fashions. It can work as an app operator, as a service catalog for operators inside your cluster. It can work as an identity management. It can work as a monitoring and logging tool. It can work as a workflow for site reliability. It can also work as a SaaS operator, in which you only use it as an orchestrator for other stuff on top of that. Be mindful that everything that KKP does, it's built upon vanilla Kubernetes. So if you still want to continue working with it, but just use the orchestration, you're more than welcome to do so. And it also works, as I mentioned, as an infrastructure as a service operator in several different clouds. So Daniel, up to you.
Yeah,
after this one, let me. So I was going to point you. So when we work with this passion and we start growing, we get to one of the main things in Internet of Things is edge computing. Why is edge computing and this traffic important? So edge computing, it's essentially the way to connect the farthest regions that you can have access to the central location that you have. However, this brings a lot of challenges, specifically where we're working with cloud, edge nodes, and edge devices. This traffic needs to be completely secure. And as it is thousands of miles away, and it's going to come with its own challenges. Probably some of you have seen it, but latency can be very, very complicated when you're working in an application where you expect things to happen fast. Now it's you, Daniel.
Thanks, Damien. Yeah, nice laying there, because when we talk about the edge stack in Ambassador, we often talk about the edge of your cluster. But as Damien hinted at there, edge computing is fascinating. And I remember a couple of years ago at KubeCon, when we could actually meet in person, this was someone from Chick-fil-A, fast food restaurant in the US, coming up to the Ambassador Labs booth and saying, oh, we run the Kubernetes cluster in every restaurant in Chick-fil-A. And I'm like, what? So if you go to Chick-fil-A in the US, there is a Kubernetes cluster running somewhere on the premises, and they use Ambassador Edge Stack, which I thought was like super cool, right? So, and to Damien's point, monitoring, really important thing, right? Being able to get a visibility at a centralized location of all these edge locations was really key, and how you manage them, how you do upgrades, like, yeah, super challenging unless you've got something like KKP to help you out. But Ambassador Edge Stack was key for the Chick-fil-A folks, as it is for folks, even if you're not running IoT solutions, even if you're doing the classic, monolith or classic microservices, just running kind of like, say, an e-commerce site or whatever your business does. Ambassador Edge Stack is a Kubernetes Ingress, and it's built on Envoy Proxy. So Envoy is a CNCF graduated project, a Cloud Native Computing Foundation graduate project. Like Envoy, I've literally watched the emergence and the rise of Envoy. Fantastic bit of technology. I'll go into a bit more detail later on about some of the nuts and bolts there. But we built, Ambassador Labs built an open source project on top of Envoy Proxy, initially called Ambassador. That's where the name of our company comes from. We donated that to the CNCF. So you can see below, or the second image below, we've actually now renamed it to Emissary Ingress, because we've kept the name. But Emissary Ingress is an incubating level CNCF project. And that's open source, community. We'd love you to get involved, pop along to the Slack channels and meet us there. But we have the Ambassador Edge Stack, which builds on top of Emissary Ingress, which provides full function ingress controller, automatic TLS, rate limiting auth, bunch of other cool stuff as well. And a final point I'll mention is that we do support straight up Kubernetes Ingress, so you can use Ingress resources. We do also provide a mapping custom resource definition, a mapping custom resource that is a bit easier to work with, in our opinion, in sort of listening to the community. They said make it easier, and is a bit more fully featured in some of the things you can do. And we'll look at that perhaps a bit in the demo as well. So thanks, Damien. Next slide, if you'd be so kind. Just a quick tour of the Ambassador Edge Stack functions. It's all about securing your microservices, it's all about observability and reliability. But for security, TLS, we give you a self-signed certificate out of the box, and super easy integration with anything that supports the ACME protocol. So personally, I use Let's Encrypt quite a bit, right? I point my Ambassador Edge Stack at Let's Encrypt. It manages the acquisition of the TLS certificates, and I can rotate them on demand as well. So to Damien's point earlier, like, I don't have to worry about TLS certificates, right? Because that's just error prone, doing all that manually. Ambassador Edge Stack does that automatically. You can set up quite advanced rate limiting, so allow lists, deny lists of IPs. You can just do things like throttling if you've got a freemium tier versus a paid for tier. Very flexible. Being able to control that front door of your application is really key for reliability, right? WAF integration, we do a lot of work with Signal Sciences, but there's many other good WAFs out there. It's basically a web application firewall. Again, it stops nefarious folks trying to enter your system. It sort of does some analysis of the payloads, seeing where the traffic's coming from, and gives you that extra layer of security. We also give you fine-grained access control, so you can use things like OIDC, OAuth. You can specify roles and specs and so forth. So folks, only admins can access this bit of the system. Developers can access this bit, for example, these kind of different things as well. But fine-grained control is really important for allowing or defining who can access what. And lastly, Ambassador Edge Stack can be deployed in any Kubernetes cluster, as Damien's point with like Kube1 and KKP. It's a multi-cloud world, right? Most of us in reality are Amazon, Google, Azure, on-prem, a bit of everything. So if you're running Kubernetes, you are good to go with the Ambassador Edge Stack. Just final thing I mentioned in relation to day two ops that Damien's mentioned before is Ambassador Cloud integrates with Ambassador Edge Stack. So if you can put some annotations on your Kubernetes services, and hopefully we'll cover this in the demo at the end, but if you can annotate, say, things like owner of the service, run books, repository location, Slack channel, like all the things that you need 3 a.m. in the morning, page has gone off, world's on fire, right? Or your system's on fire. You can look at this information on the Kubernetes services itself, but Ambassador Cloud makes it even easier to visualize and find that information. So I'll give you a bit of a demo in that in the end, but we think service catalogs are really valuable. Once you've got a certain size of system, being able to visualize those services is really critical for day 2 operations. And we've got a bunch of other integrations with our Telepresence CNCF open source tool, and we're doing a lot of work with the Argo community for Argo CD and Argo rollouts for shipping or deploying your application. So if you want to know more, hit me up afterwards. But it's really key that Ingress is so critical to all the ways you deploy and release software into your service, into your system. Over to you, Damien, on this one. Oh, I think you're muted, Damien.
Oh, really? I was. It's the bane of the future. So, okay. So before we jump into the demo, I just want to give you a little bit of the information regarding how is the architecture built for this one. How is this going to look like from an architectural standpoint? How are you going to eat it? So, in terms of architecture, Kube1, it uses several different tools, but you can think about it as building blocks. It uses KubeADM to provision and control and join the control planes and handle the cluster upgrades. We have a machine controller that is cluster-based API that is going to manage the worker nodes, and you're going to get all the other elements that you normally have in a Kubernetes architecture. You're going to get your API, you're going to get your GCD, machine controller, scheduler, and you're going to get your control plane of all for that. The difference is that this is out-of-the-box compliant and built to stand up an initial cluster and make sure that you get everything up and running from the beginning. So when you're building an initial cluster, it's going to look something like this. You're going to have a Kube1 cluster, then it's going to be comprised of 3 master nodes, and it's going to be comprised of 3 worker nodes. The reason why this architecture needs to be like this is because you want to make sure that you have resiliency, you have self-healing, but you also have the ability to have some of the services that KKP is going to build on top of that and is going to be handled. Now, this is something important. So KKP, the Kubermatic Kubernetes Platform, doesn't necessarily need to go in a Kube1 cluster. You can put it in any cluster of your choosing. However, the way that we architectural, it integrates faster and easier from an installation standpoint, so you can stand it up in a matter of minutes. So it will look something like this. You're going to have a Kube1 cluster, and then you're going to have the Kubermatic Kubernetes Platform, which is going to act as the infrastructure as a service operator. That is going to have all the elements inside. You're going to get your API, you're going to get your machine controllers, and you're going to get your user interface. And once that is done, we work with the concept of seeding. So to put it bluntly, a seed, it's a master plane, a master cluster, a master region that you're working with. So think about it as having a house and assigning rooms to each and everybody in your house. It's the same way. Your house is the complete KKP, a seed is each one of the rooms that you assign to everybody. So if you grow bigger, it's going to look something similar to this. You can have your Kubernetes master cluster in one cloud, in one region. You can have one in OpenStack. You can have one on-prem in VMware. It's fully compliant with KubeVirt and VMware. I'm actually going to show you one of the labs that I prepared for today. It's in my own personal premise. So it's built with golden images, which for those of you who have been working AppOps, a golden image, it's an image that you build of an operating system with an application inside it that you push the upgrades to. So it's going to look something like this. And you can have your master seed cluster, and you can handle multiple use of clusters in multiple different regions, having governance of the data across multiple clouds, which it's going to be very interesting when you move to these terms of edge computing and edge location. Back to you, Daniel.
Thanks, Darren. Yeah, lovely intro there to the top level overview of Kubernetes. Let's dive a little deeper now into the edge stack itself. Now, I hinted earlier on that Envoy Proxy is kind of the engine, if you like, of Ambassador Edge Stack. So what Ambassador Edge Stack does is takes user-friendly declarative config and maps it into Envoy config. Now, Envoy is super powerful, but configuring it is not really for humans. The things we've mentioned a few times, Envoy is really designed to be configured by machines, right? Designed to be configured by other computing processes. So what we do is we say, here's a nice custom resource that says mappings, this endpoint to this service, and we then translate all of the associated Envoy proxy config from your declaration in a nice simple construct. So you just define mappings, Ambassador Edge stack, it's constantly looking for those changes in Kubernetes, and it relays all the changes onto Envoy proxy. So in the Ambassador Edge stack, the hot path for traffic, if you like, where all the traffic is flowing through, is simply Envoy proxy. We're not getting in the way, we're not adding lots of extra layers or whatever. Ambassador Edge stack is a control plane, a way of controlling Envoy proxy. And its Ambassador Edge stack is specifically configured for controlling the API gateway, the ingress, or north-south, there's many names for it, but it's specifically been built with that use case in mind. Because you see Envoy proxy in service meshes and other things too, and it's really good there as well. But the Ambassador Edge stack is focused on that front door use case, right? Things where you are going to be doing a lot of increased security, because it's where the outside of the world meets your internal world. If you'd mind to go to the next slide, David. Oh, I think it's straight back to you. Nice and easy.
Smooth. Smooth. Yeah. So one of the main things that we were talking at the beginning is that in order to have a very well day two operations, you want to make sure that you are able to monitor and keep track of everything. So this is when we dig deeper. So Ambassador is going to allow us to monitor the traffic, ingress and egress rules. It's going to allow us to understand how things are actually working. But then we need to see what is actually happening inside our cluster. So KKP, as I mentioned, is going to have a control plane that is deployed inside Kubernetes, which means you're going to have visibility upon the following elements, which is normal in any Kubernetes cluster that you work. You're going to be able to have visibility upon the API server, control manager, scheduler, etcd, core DNS. Now, as KKP is built on top of vanilla Kubernetes, you're also going to have access to the vanilla Kubernetes dashboard and the metric server that it comes with it. However, when we talk about alerting and monitoring, we have to go deeper into this one. And for those of you into DevOps, this is probably sound very familiar. It did sound familiar for me in the past. I suffer with this through a lot when things go very big. And this is the normal stack that you would see in a Kubernetes cluster. You will use normally Prometheus for the scrapping of the application metrics. You will use Loki for the application logs. You will use Grafana for the user interface logs and metrics. And then you can use Thanos for some cluster of the storage and some long storage metrics. And as your cluster grows bigger, things grow bigger. So if you have a normal stack, and you grow into multiple stacks, means that you have to deploy this stack over and over and over again, which means that your engineer or you yourself will have to actually take a look at this individually. So the way that we approach this and the way that we like to solve upon this is that we went into a multi-cloud monitoring. So if you remember the diagram that I showed you before, KKP is built upon a hierarchical architecture, meaning that you have a master on top of everything that is via seeding connecting all your elements. And this is true the same way when you're working with monitoring. The way what this was designed in way, and we approach it this way, is so we could implement the MLA stack for KKP to make it out of the box first. Second, that you can flag things easily via API, that you can handle these day two operations in user clusters, in elements that are stateless or tiny, leaving low footprint for the customers, and basically putting all those logins into a single place, meaning that you don't need the same amount of space in each one of the worker nodes to store all of this. You just need it in the main cluster that is going to handle the main seeding, which in terms, for example, in business, the amount of money that you're saving in storage is massive, because you're getting a single pane of glass for thousands of clusters to access all the logs and all the metrics across all of the clusters. And this is true if you have multi-tenancy, or if you have prem environment or if you have cloud environments. So in the end, all this architecture will look something like this. You will have a master seed cluster where you will have your login namespace. You will have a KKP Kubermatic namespace with the elements, and then you will have a monitoring namespace that is gonna have the alert manager, Grafana Prometheus, and then you're gonna have your user clusters that are gonna have each one of them their own control plane, their own Prometheus, their own open VPN server, and their own machine controllers connected to the clusters. And then you get your applications, and then you get everything into a single monitoring namespace. So now, Daniel, back to you so you can give us a glimpse of this one.
Oh, also, I thought you were going to do the KKP demo first.
Really? Oh, good. Then let's jump into the demo, guys. So we're going to show you the main goal of our demo today is that I want to show you how the installation process is done. I'm not going to do it directly. I'm going to show you how this looks from Visual Studio, the files, how the process is, and how easy it is to actually set it up. Then I'm going to jump into the infrastructure, show you some of the cluster creation in a single control plane, set up some worker nodes, and then Daniel is going to show you how to deploy the Ambassador stack and how it works and how it's used. All right. And before we jump into that, I want to take the opportunity, guys, to invite you to Container Days next week. It's gonna be very, very cool. I'm gonna be a speaker over there, so if you like the way I talk, you can join me again.
Me too, Damien. Me too, right? Virtually.
Oh, Daniel is gonna be as well there, and he's awesome.
Virtual high fives.
Yeah, yep. And it's free for those you want to join online. For those in the European Union, I think Caroline might give you some more information, but it will be awesome to have you there. So before we jump into the demo, guys, do you have any questions that you wanna reach out directly? You can type it down in the questions and answer, or just let us know. Excellent.
Or is everyone super keen for the demo, Damien, right? There's always an element of danger with the demo, right? People are like, go on, do the demo.
Yeah, when things break.
Yeah, exactly.
All right, so the first thing that I want to show you here is how KKP looks like. I want to show you how this actually looks like. So this is the Kubermatic Kubernetes Platform. This is what you get when you do the installation process. This is how the interface is going to look like. I have two versions over here, one that I prepare for the demo, another one that it's my personal usage. And this one you see here, the white one, is the community edition, is the open source version that you can get anywhere. You can go into our Git and get it out. I also prepare in my personal Git, you will find all the installation steps that you will ever need in case you need them. So it's going to look something similar fashion to this. You're going to be able to see your projects. You're going to be able to see your user information. When you go into the projects, you're going to have visibility of all the clusters that you have ready in here. You're going to have the ability to see SSH keys. You're going to be able to see the members of your organization, and you're going to be able to handle service accounts. So before I go into creating a cluster, I'm going to show you how this looks from the background. So as I mentioned, KKP, it's done via, everything is done via HashiCorp Terraform. Everything is done directly via using YAML files. So the process that we follow when we're doing this is that the first thing that we need to do, and let me see if I can actually move this away from here. It's awesome. It was not allowing me to move this. Is that we are going to be able to configure all the information that we need using terraforming. So the first thing is that you're going to be able to configure your cluster name. You're going to be able to select your SSH public key, and then you're going to be able to do all the configuration that you need. Obviously, depending the cloud provider that you're working on, for example, if you're working in AWS or if you're working with any other provider, you will need to do the export of your key. So I'm just gonna go real quick here and export my username and my export AWS key and my secret to make sure that I got this right. And just start your SSH agent as usual. So then we need to run the terraforming in it. I'm not going to run it right now, but once you run it, what you're going to get, and let me just click over here, you're going to get all the configurations regarding the output. So I have this over here. You're going to get the output of your initial cluster. So this one that I'm showing you here is the one that it's normally used for Azure. I'm going to show you the one that I use for my specific lab that I showed you that I got in my lab. So as I mentioned, KKP works with a 3 cluster, 3 master, 2 nodes for Kube1, and you're going to run everything via declarative way. You can prepare this terraforming whatever way you want to see it, any way that you want to see it, any way that you want to put it. And once you do the installation of this one, what you're going to get is this. You're going to get your three main instances, your 3 master nodes, and then you're going to get your 3 worker nodes. And also, you're going to get a bastion in case you actually want to connect directly to that. Once you do that, we need to jump into the example of a city. So as I mentioned, a seed is the specific master in a cluster in a cloud environment that you're going to work with. So for my seeding, for the lab that I prepared specifically for you guys, I added my namespace is called Kubermatic. I added my region in Paris, and I added my data centers in Frankfurt. The reason why I did that is so I can have governance of the data. So Kubermatic is based in Hamburg. So I wanted to make sure that I keep the governance of my data in the specific place where my company is located. So this means that my main cluster, as you see it here, is going to sit down in the Paris region, and any subsequent cluster that I'm going to create is going to sit down in the Frankfurt region. So I'm going to show you real quick how this works. I don't have anything in this region, so I'm just going to go here in my project, and you have 2 ways to connect. You can either connect an existing cluster that you have already, or you can create a new cluster. So I'm just going to create a new cluster over here. My provider is going to be AWS, and the region is Frankfurt, which matches the seeding that I created. You got to select the cluster name, and you can specify which kubelet version and control plane version you're going to have. So now, usually this is always updated to the latest version. And the one that you see here in the version is the most stable one. So when you go here, 1.19.9 is my personal favorite, is the most stable so far. So it's the one that I like to use it. We go into next. And then here, you have the ability to create a preset. So when you're working with big enterprises or in your own team, you can create a preset of security groups, root tables, instance names, control planes, IRNs, or you can just leave everything by default. So I'm going to go over here and I'm going to create an access key, and I'm going to put my secret here as well. Oh, sorry. So as you see here, this account is not working. This account I had deactivated. So you got to make sure that every time that you do something similar to this fashion, you're actually available to have everything up and running. So I wanted to show you this so you understand how secure this environment can get. So I'm going to jump into my second lab here, where you're actually going to be able to see, because it takes a while to create the deployment. So when you go into a better deployment, and we're going to create the cluster again, we're going to go to AWS, and we're going to go to Frankfurt region. We're going to select the name, and I'm going to select the kubelet version. I'm going to select 1.19.9, and you can select the container runtime. You hit next, and I'm going to select my preset, which comes with all the access key and all the information that I require. And you select the name, the amount of replicas that you want. I'm going to select 3 replicas. I'm going to put it in Ubuntu. I'm going to select the smallest one that I have, and I'm going to leave everything else by default. So as you see here, there's an MIID. When we were talking about day two operations, and I mentioned golden images, this is one key element that I've seen used and I've used personally. You can deploy your applications via golden images if you're working in a green-blue architecture, meaning that you're working in a development pre-prod or prod environment, and you can promote your applications directly very, very easily. So it also has support for Spawn instances. I'm going to leave it default, and I'm going to hit next. As you see here, it's going to come to the whatever options you have. And you have the ability to do two main things. You can save the cluster template. So you can create for the clusters along the line, or you can create the cluster. So I'm just going to create this cluster directly. And as you see here, it's going to start spinning up everything the way that you need it to, the way that you specified to. Now, while this one goes up, let me go back to the project and show you something else. You have the ability to have several clusters from several different clouds, from several different regions in the same project, which means that you have the ability to whitelist. So in terms of day two operations and bootstrapping of this, means that you can do, you can have several clusters created in here and governance of the data. So I'm gonna go into this cluster over here, and I wanna show you how this looks like. I created this cluster prior to our session. So if you see here, you're going to get your master session, you're going to get your cluster ID, you're going to get all the information regarding your cluster. Here down below, you're going to be able to see the events that you have. You're going to be able to see the RBAC, which means who is doing what. You can add bindings. So for example, I can add Daniel here at demo.com, and I can attach him to a specific role, to a specific namespace, and add the binding, which means that Daniel is always going to have access to this cluster, but only for specific functions. And you also have the ability to control the atoms that you're working with. Remember, I mentioned we are completely open source. When we work in open source, we want to make sure that we are upstream compatible, that we can bring everybody to the party and that we can integrate everything. So we have the ability to put any operator that you want. These are my favorites. For example, I love cluster alpha scalar, one of my personal favorites. Once you install it, it's going to install it directly in any machine deployments that you have. So now, if you go to the worker nodes, and I made this on purpose that they're not working, so you can see how it's actually, how is the alerting going to look like. You're going to get your kubelet version, you're going to get your replicas, you're going to get the Azure, you're going to get everything that you're going to see in your cluster. But you're also going to have visibility individually at each one of the nodes. As you see here, you're going to have visibility of the system, the OS, everything that it's supposed to work. And down below, this is why I made this on purpose. You're going to have alerting and visibility of everything that is happening without actually having to go into the cloud provider and check what's going on. So if you see here, my machines were not able to be created because my disk is too small. So, man, how do I do this? So I want to change this. I just go over here and I just increase directly the space that I have. I can do any other changes that I wanted to this cluster specifically here. So if I wanted, for example, if I wanted to change the golden image of my application, I just put the new ID here and I let it roll, right? And that's actually gonna give me the ability to change everything directly. Now remember that you need to select when you work with Kubernetes and you do the upgrades, the sizes and the machines when you upgrade them, they're going to be recreated. What KKP does is that it makes sure when you create everything and recreate it, your application is never going to have any downtime to it. So if you see here, I already have my new machine deployment. I got my new space, and I'm going to save it. And so I don't want to take too much time so Daniel can show you the ingress. But once you save that out, KKP is going to automatically, if you see here, is going to update the deployments, and it's going to start deploying the new machines with the new settings that I needed without actually providing any downtime. So if I go back to my project and I go back here to the other cluster, you see that everything is coming up. So now here to the left, you're going to be able to see your elements of monitoring. You're going to have Grafana out of the box, where you are going to be able to centralize the operations. So you can centralize it either by node, by project, or by the whole infrastructure. You can create it any way that you want it, and this is going to come up out of the box, including Thanos for storage. So, Daniel, feel free to take over. I'm more than happy, guys. If you're interested in this one, in the interest of time, I prepare a Git. Well, you can actually, in the presentation, you can reach out to my Git. Here is all the installation files. I have prepared a couple of things where you can take a look at that. Some of my personal guides for the installation of the community-driven edition. And anything you need, just hit me up. Okay. All yours, Daniel.
Awesome, awesome. Right, let me just share my screen. Oh, I think you've got to stop sharing yours, Damon. That's all right.
Yes, sir.
There you are.
All yours.
Super. So just to give you the bootstrapping for Ambassador Edge Stack, pop along to getambassador.io, docs Edge Stack. I'm going to cough. Excuse me. Talking too much today. That's the challenge. So you pop along to our website. There's a Helm install, Helm 2 and 3. You can bootstrap the Kubernetes YAML. There's a CLI installing tool. So typically with things like KKP, as Damon said, you use obviously Terraform to define everything. We're a big fan of using Helm and YAML. Keep everything declarative. The CLI tools are more really for bootstrapping and playing around with things. So once you've got installed, let me just bring up my terminal now. You can see I've got a Kubernetes cluster. Excuse me 1 second. Oh dear, apologies everyone. The voice is going there. You can see I've got a standard Kubernetes cluster here that I've spun up. Bunch of interesting things in the namespace. I've got some emoji voto demos, which is the buoyant Linkerd folks. It's a great demo for understanding network namespaces and routing traffic around. Got some Argo CD and some other things going on here. But standard Kubernetes cluster, I've A-list kubectl on my local machine to K, makes it nice and easier, right? So I've just done a K get namespaces here. This is all the namespaces in my cluster. If I was to do a K get services in the namespace of Ambassador, I've installed Ambassador already. I just use Helm, standard Helm install. You can see I've got a bunch of services related to Ambassador. We have the Ambassador service itself, Redis for maintaining state around rate limiting and auth and a few other things like that. And we have a couple other utility services in the namespace too. Now I can do a describe on Ambassador. For example, if I just do K describe service of Ambassador in the namespace of Ambassador, we'll get a bunch of useful information about that service. So you can see, for example, it is a load balancer, and we've exposed it on an external IP here, courtesy of we're running it, I think, in Google Cloud, this example. And we're listening on port 80 for traffic and port 443 because we've got TLS enabled as well. If I scroll up to where I initiated the command, and you can see here I did my K describe command, there's a bunch of standard Kubernetes information that this describe gives you, but I've also annotated a bunch of things. As I mentioned earlier on, I've literally just standard Kubernetes annotations, much like labels, but much more free form. So you can see I've got my labels here, which we're using for selector purposes. I've added annotations in my YAML, and these are just useful if you're, say, doing a K describe, looking around the cluster, things are on fire. This service looks to be struggling. We can, for example, see links to who the owner is of this service, where the repository is, where the support channel is, these kind of things. And this info here in our Ambassador Cloud service, which I mentioned earlier on, it actually gets rendered nicely. So we're looking at the web service. This is our service catalog view into the cluster. We're looking at the web service in the CLI. So if I click on web service here, drill in, you can see all the information that was on the annotations is actually now rendered in this nice view. So we literally parse the Kubernetes config into our cloud view here. It's free to sign up. You can sign up and view all your services that Edge Stack is running with, or Emissary Ingress too. And to Damien's point, you can very easily link off to your Grafana dashboards. So if you want to see some metrics related to Ingress, we can see here, this is like a standard Ambassador dashboard. We expose metrics via the Prometheus endpoint. But we've got, if you go, I think it's port 8877/metrics. You can scrape all your Prometheus metrics. We can also push Envoy stats in statsd format or Datadog. So, Datadog D format. So it's super easy to collect all your metrics. And I've just linked off this dashboard, nice and convenient, from my service metadata. If we go back to the CLI, I'll just clear my screen to make it a bit easier. If I just do a get hosts, for example, in the namespace of Ambassador, I should have a bunch of hosts you can see running. So you can use things like SNI. You can have multiple hosts, multiple domain names being served via one Ambassador Edge Stack. So your one cluster can be running many web domains. I think I've actually got, where is it? Move zoom around a little bit. Emoji Voto running here. So one of the hosts we can see in the list. If I click refresh, this is an example app you can play around with. It's all secured via TLS, courtesy of Let's Encrypt. So super easy to get up and running. I would just say, if I just list in my terminal here, defining mappings, so how you want to map endpoints, so slash or slash payment service, slash voting service, you define these through mapping custom resources. So if I just do actually let's just do Vim, look at it, nice and easy, right? You can see this is a very simple mapping custom resource that literally says, map the prefix of slash, so the root of your domain name, to a backend service, web-service, running in the Emoji Voto namespace on port 80. So if anyone's familiar with many other ingresses or proxies, very similar, declarative Kubernetes native way of defining mappings. You can add additional information such as rate limiting on here. You can add authentication. If you pop in the docs, I've got a few links here. There's your getting started link, but I've got the monitoring link here. If you want to find out more information, pop into the docs. We've got everything around protecting services such as auth. You can use Google, Keycloak, Otka, many of the different IDPs, and some nice information there. If you wanted to configure, say, rate limiting, super important, you can do that, and it's all declarative too. To Damien's point, nice and easy if you've got declarative config. I think we're getting dangerously close to time there, folks, aren't we? So shall I pause for a second and just say they don't got any questions? And if not, no worries. You can always find us afterwards via email or Twitter or GitHub, Damien. We're around quite a few places, right?
Excellent. Yeah, we do got a couple of questions in the chat. So if you want to take a look at that, I answer a couple of them. But to put it, one of them is network bridge required for every Kubernetes cluster deployment, or is it only required for when Kubernetes cluster is deployed on bare metal or when Kubernetes cluster is installed in virtual machines?
Interesting questions. If I understand correctly, you will always need an ingress, a load balancer, to get traffic from your external users to your backend services. So there's multiple ways you can do it. You can use sort of standard load balancers, particularly if you're using things like TCP or gRPC, right, from mobile clients. You may not need something fancy, but if you're exposing a website or you want some additional functionality, you do need something like an API gateway, a richer ingress. But you always need that way of bridging the external world into the internal cluster networking namespace.
Does that answer your question, dear anonymous attendee? Excellent.
Brilliant. You can always find me on the various Slacks, the CNCF Slack, Kubernetes Slack, if you want to ask any more questions too.
Excellent. Then I thank you dearly, guys, for having us. Similar to Daniel, anything you guys need in Slack, you can find me as well. GitHub as well. Anything you need, more than happy to reply and work with you guys.
Brilliant. It's been fun. Thanks, everyone.
Excellent.
Yeah, also thank you from my side. I'm sorry that we needed to stop and interrupt the demo, but I'm pretty sure if there are any questions, you know the ways how to reach out to the guys. So thank you very much for joining today. Hopefully see many of you next week for Container Days. And yeah, enjoy your evening.
Thanks, everyone.
Bye.
Bye.